Welcome back. We'll continue with the discussion on discrete Fourier transform. Let's start. So today we shall solve one important problem of discrete time Fourier transform. But before we do that, let us revisit the expressions. Let's write the expression of discrete Fourier transform. This is given by summation in running to 0 to n minus 1 x of n e to the power of j 2 pi by n kn when k is 0, 1, and a minus 1, and inverse discrete Fourier transform expression is 1 by n k running from 0 to n minus 1 x of k e to the this is plus and k n is equal to 0. Now see, this expression says x of n is given and we can compute x of k, where k is 0, 1, 2, 3 up to n. This expression says x of k is given, then x of n, we compute x of n. Now whether I say x of n or x of k, I'm talking about the same information or same quantity. Remember that one is in time domain description, another is the frequency domain description. Now today we shall solve one important problem, like how to compute the DFT of constant. DFT of constant. And let's say 4-point DFT of a constant. So 4-point DFT of a constant. Now, what do you mean by a constant? Now, let's suppose the constant value is 1. So for simplicity, let's say constant value is 1. So I'm saying x of an is equal a constant sequence. That's the meaning of constant. So if I plot this, so if we plot this, so this is our x of n. So the signal is constant. So we are saying that this is our sequence. This is our sequence. So 0, 1, 2, 3. This is our sequence. This is the constant sequence, and the value of the constant is 1. Right? This is 1. This is 1. This 1. And our goal is to compute x of k. In other words, what's the value of x of 0? What's the value of x of 1? X of 2? And x of 3. Remember, if x of n is given you and it has only 4 sample points, then you have to compute the 4 points of x of k, or 4 values of x of k. Remember, that's the meaning of 4 points. Okay, let's start. So let's use the definition of this. So x of k we know is given by summation n running from 0 to n minus 1. Sorry, this is small x of n e to the power of minus j 2 pi by n k. So this is our expression in the values of this one varying from 0 to n minus 1. So we have to compute the 4 point, means n is equal to 4, means capital N is equal to 4. So this is 0 to 3 x of n e to the power of minus j 2 pi by 4 kn. And if you simplify this, this will be 0 to 3 x of n e to the power of j pi by 2 kn. And substituting the values of n, we get x of k. So substituting the values of x of n, this will be x of 0 e to the power of 0, x of 1 e to the power of j pi by 2 k plus x of 2 e to the power of j pi by 2 2k plus x of 3 e to the power of minus j pi by 2 3k, right? So substituting the value of x of 0, x of 1, x of 2, and x of 3, these all values are 1. Right? So e raised by 0 is 1, so it will be 1 e to the power of minus j pi by 2 k plus e to the power of j pi k, because pi 2 and 12 cancel. This will be e to the power of j 3 by pi to k, right? So this is our x of k. Now put k equal to 0, put k equal to 1, k equal to 2, and k equal to 3, you will get the values of x of 0, x of 1, and x of 2. So when we put k equal to 0, this will be x of 0, this is 1, e to the power of 0 is 1, e to the power of 0 is 1, e to the power of 0 is 1. So this is 4. And then put k equal to 1. So this will be x of 1, x of 1 is 1, plus e to the power of minus j pi by 2, plus e to the power of minus j pi, plus e to the power of minus j 3 pi by 2, 1. Because k is 1. Now let me simplify this. This is 1, this will be minus j. How? Because e to the power of j theta is cos theta plus j sine, right? So what will be e to the minus j pi by 2? This will be simply cos of pi by 2 minus j sine pi by 2. Right? If this is minus, this is becoming minus. This is 0, this is 1, so it will be minus j. This is minus 1 because cos pi by pi is minus 1 and cos sine pi is 0. This will be plus j. This will be plus j because sine 3 pi by 2 is minus 1. Sine 3 by 3 pi by 2 is minus 1, so this minus and minus will become plus. So this is 1 minus j minus 1 plus j. This is equal to 0. So x of 1 is 0. You can check it. Now put k equal to 2. Put k equal to 2 here in this expression. So it will be 1 plus e to the power of minus j pi by 2 times 2 plus e to the power of minus j 2 pi plus e to the power of minus j 3 pi by 2 times 2. Now you can see this 2 and this 2 cancels, this 2 and this 2 cancels. We are left with this is 1 plus e to the power of minus j pi is again minus 1. Please check the values. This will be e to the power of 2 pi minus j 2 pi is 1, e to the power of minus 3 pi is 1. So again 1 minus 1, 1 minus 1 is 0. So this is again 0. Now x of 3 means when k is equal to 3, this will be 1. Then what's the next value? E to the power of minus j 2 pi by times 3, e to the power of minus j 2 pi times how much? 3 pi. Added 3. So this is 3 pi. I hope I'm right. Right. So this is plus e to the power of minus j 3 pi by 2 times 3. So this will be 1 plus e to the power of minus j 2 pi 3 pi by 2 to the power of minus j 3 pi e to the power of minus 9 pi by 2. Please check the computations. So this is 1, this is minus j. Please check the value. This is minus 1. 9 pi by 2 is plus g. This will be plus g because there is minus here. This will be plus g. Please check the values. So you can see again this is equal to 0. So the values of x of k, so the values of x of k, four values are 4, 0, 0, and 0. When our x of n was, means when the x of n time domain sequence is 1, 1, 1, 1. Now, let's interpret the result. This is very, very important point. Please pay attention what I'm going to say next. See, x of n is a constant signal. X of n, you can check, we already plotted. This is a constant sequence. So this is a constant sequence. So this is our sequence. So this is the sequence we have got. So this is a constant sequence. Now, what should happen in the frequency domain simultaneously? So this is a constant. That means all the points should be 0, means all the omega values should be 0 except the constant frequency. Constant frequency means 0 frequency. 0 frequency value, we should have only 0 frequency, and the rest of the frequencies should be 0. That is the literal meaning of this, because our signal is constant. It's not changing with time. It's not changing with time because it's always constant. So what should happen in the frequency? We should have omega equal to 0 point, rest of the sample should be 0, means the rest of the frequency should be 0. And this is quite obvious from this. You can check x of k is also 0 only. x of k is all the values are 0 except when, so this is 4, this is k equal to 0. So 0, let us suppose this is 0 when k is equal to 1, when k is equal to 2, and when k is equal. Okay, so this is in terms of, now in terms of omega, omega k. So in terms of omega, which frequency is this? This is 0 frequency because omega k is equal to 2 pi by n k. When k is equal to 0, this is 0. When k is equal to 1, n is equal to 4. So this will be pi by 2 frequency. And this corresponds to pi by 2 frequency. What does this 2 correspond to? This means 2 pi by 2 means pi frequency. So when omega is equal to pi, the value is 0. This is 3 pi by 2 frequency. So this is 3 pi by 2 frequency. All right. So this is in terms of omega. I hope you have got the intuitive idea, because the signal, our time domain signal, is a constant signal, so it won't change with time. That indirectly means that the frequency domain represent should have only 0 frequency. Rest of the components should be 0, and that's what the result tells you. That's what the result shows here. And this is very, very intuitive idea of the sequence. All right. I hope you have got the idea. Now please try it in the MATLAB. So please try this in the MATLAB, where x is this time 1, and check the capital X. Capital X you check by typing FFT X, then enter it and check the IFT also, whether you will get the result back up now from this. All right. So please check it yourself and please interpret the result. So for a constant, the rest of the sample should be 0. Now here is an assignment for you guys. Please solve it yourself. Question 1 is when x of n is 1, 0, 1, 0. So compute the DFT, means the 4-point DFT of this sequence. Now second question is when x of n is 1, 2, 1, 2. Compute the DFT, but the 6-point DFT. 6-point DFT of this sequence. That's the second assignment. Now third question is x of n is 1, minus 1, 1, minus 1, 1, minus 1. So compute the 8-point DFT of this. Now for question number 2, I said there are only 4 points given to you, but I have told you compute the 6-point DFT. That means you have to pad yourself x of n 2 zeros. So what you'll do, so this will give you the 6 points of x of n, then you'll compute the DFT of this sequence, not this sequence, right? That's the meaning. So if the question asks us if there are 5 points, suppose given, or 5 samples given you, and you are told to compute a 10-point DFT, then add zeros, add those much of zeros. Here you will add 5 zeros in that case, right? So compute the DFT of these sequence. Let me end this session here. In the next session, we'll see the matrix formulation of the sequence of this DFT.